first speaker for today is Stanislav Lebedev. Stanislav will be talking about hybrid model for predicting oil and gas production. And Stanislav, it's your time. Please go ahead.
Yes, hello. Hello.
Hello, we can hear you. We can see your screen. Perfect.
Okay. Hello, colleagues. I am Stanislav Lebedev, and I would like to tell you about our hybrid model. First of all, the underlying problem of finding the flow rates is currently being solved by a method based on numerical differentiation of math physics equations. As you know, the most of mathematical models fall under the following scheme. Different equations describe certain laws of nature, and to preserve locality, you need to divide objects into cells, or in other words, cover them with a grid. Accounting for various specialties things such as anomalies becomes extremely difficult with this approach, because either you need to complicate the equations or significantly reduce the grid, or even both. All this leads to decrease the speed of calculation, and it is very bad. By the way, it is not particularly large because the number of cells is significantly, and parameters, and even in medium-sized fields. So it is very big problems nowadays. On another hand, you can use optimization models, set some functionality and optimize it. For example, if we assume that wells are connected by pipes, the goal to find the optimal function which depends on parameters of these pipes. Due to their significantly lower computation complexity, such model can be called light. Due to the flexibility of this approach, the accuracy is usually lower than classical models. For example, the CRM model, the flow is expressed as a function of certain number of parameters. They computed to give the minimum error on the known data. A big advantage of this approach is that values of these parameters themselves can be generally very useful, but this approach is very difficult also, because you need to write down this function. So today we have two different ways. We can use standard classic models that very slow but have a very big accuracy. Or we can use light mathematical model. They are not very accurate, but very fast. It is very important to say that both of these ways don't use ML, machine learning, and it's not very good. The main bottleneck of optimization model is the need to write down the function, as I said before. So it is very difficult to make very complexity model. But the machine learning methods give us an opportunity to hide the internal structure. So we can improve accuracy and it will work as fast as standard optimization model, but better. But to improve accuracy and to increase accuracy, it was proposed to use the so-called hybrid approach. Firstly, the coefficient of CRM models computers. After that, we make an initial forecast of liquid flow based on this forecast and some other source data. We can use any data we want. We can use geological data. We can not use it. We can use everything we want, and we think that it is good to use on this step. So use based on these things, machine learning algorithms trained to make more accurate predictions. The experiments showed us that approach is effective. As you can see, the forecasts of CRM models really need to be refined. Earlier, we use LSTM autoencoders in ML model. It's special type of neural networks, recurrent neural networks, but it is very difficult, and they are very slow, and we think that it's not very good to use them. So now we can use a wide range of models and to give right now we use AfterML framework TPOD. It's automatically selects the optimal pipeline. So it is very good, and we haven't to use only one model as before. But for industry, the total production is often more important than the dynamics on the previous slide. So according to this metric, our model also shows a good result. Unfortunately, we haven't yet been able to perform any compression test with the classic models, but we are sure that we are much more faster, but we don't know how. What about accuracy? Maybe we better, maybe we worse. We haven't done this. To sum up the above, I would like to note the following things. First, the hybrid approach is a new stage in the development of reservoir models. A combination of light, physical, and machine learning models in which the reservoirs represents in some latent, non-latent space allows us to increase the accuracy of forecasting. I would like to highlight that it is enough to know the information received from wells. Mainly we needn't any other information, but we can and we use it because it is important, but we have this opportunity. And also the gibberit is very adaptive. I started with idea that if you want to increase results of classic models, you need to change different equation. It is very difficult sometimes. But to increase the result of gibberit, you have more ways. Improve first step light models, improve ML models, or maybe add some more steps, or get bad data or pre-process it better. Also, I want to say that it is not the only way to use ML in gibberit approaches. As I can see, the team from Skoltech that use another way. I hope they will tell us a lot today about this, but they use another way from me. So thank you for attention. I'm ready for questions.
Thank you, Stanislav. You are exactly on time. We have 5 minutes for questions and answers. I do not see the questions in the chat.
Yes, we have one question. Nikolai Smirnov.
It is really strange because I do not see the question in the chat. If you can please
but
read.
it was not in the chat. I just raised my hand.
Okay, please go ahead.
I don't know how to switch on video, unfortunately. That's why I'm just, but nevertheless. So the question, you emphasized that the hybrid model doesn't need any geological data. And so that that initiates the question. So can you hear me? Is it okay?
Yes.
Okay.
Very well.
So that initiates a question. So if we have some standard simulator, for example, T-Navigator by Kirill Bogachev, which you mentioned, then we can use it since it has all geological and data and a lot. So we can use it for any, just deposit for any oil field, just providing proper initial conditions. And what about your hybrid model? I understand that it can be well trained using machine learning for some special deposit or for some special oil field. Or a set of wells, but how we can just use it for a different oil field with different geological data, and will it be possible or not? This is the question.
Yes, it is very interesting question because it is open question for us when we make our model. We think about that you have history data of some field. You train your algorithms, then you can forecast the everything on this field. But we understand in process, we understand that maybe it's a good idea to try train on one field and then forecast in another field. It is very machine learning methods give us this opportunity, but CRM model is it's the bottleneck of this of this method, because TRM model needs to have to forecast on the wells where it was trained. I hope I answer your question.
Yes, well, thank you very much. You just confirmed me in the idea that if one needs to make predictions on some other oil field, in some other oil field, then it is necessary to collect the history from that particular oil field,
Yes,
and
yes.
then use machine learning procedures in order just hopefully to predict, making it possible to predict some just analogical behavior, which maybe will not take into account some additional actions. For example, if there will be some new hydraulic fractures arranged, so what will be with the, it's already the second question, excuse me. What will be with the predictions? Can your model predict some active just intrusion into the subterranean environment?
I don't understand the question. Can you repeat,
Okay,
please?
okay. I'll tell in a different way, formulate. For example, there exists a model which is trained based on the data, on the historical data of some oil field. And then the model is working and it makes rather good predictions. And then someone decides to make several new hydraulic fractures in this oil field, which will change all the subterranean hydrodynamics. Will
Yes.
it be possible that your model will react on this because it still uses some data from the wells?
Yes, it is a big limitation of our model nowadays. We need to use the fields and so on in the same condition as in the past. So we cannot, for example, we cannot use our model if you change the status of well, if or if the geological change seriously. So it is a big problem, but a big thing that we can use, that we can retrain the machine learning step, and it will train faster. And it's a good it's a good point that if anything change, we can more faster react for this. As I understand, in Navigator, you need to compute everything from the start. So it's as for me, in our model, it's maybe better realize this.
No, I do not think that it is necessary in all simulators. For example, in Eclipse as well, or in stars, there is no need to compute everything from the very beginning. Just the computations from the very beginning are done for the validating purposes on some oil well. And then after you just compute, you make forecasts. Of course, it's time consuming, but if there are some additional changes, for example, in geological structure, there is no need computing everything from the very beginning. Wow. But nevertheless, thank you very much. I received just the satisfactory, absolutely satisfactory questions. And so I think I consumed all the time for questions, and I'm very sorry for that.
Thank you.
Nikolai, Stanislav, thank you very much for the very good discussion.